Okay, what is this thing I've written on the board called?
Absolute value inequality.
Absolute value inequality. Yeah. Is it true, false, or open? Open. Are the solutions numbers or pairs? Numbers, because
There's one variable.
only one variable. How did we solve this equation before? We split it up into its two cases. What are the two cases? Good. And it's because this thing is a piecewise function, right?
Yes.
It's either x or it's negative x, depending if x is greater or equal to 0, x is less than 0. These inequalities are going to have a lot more than a couple. Okay, so let me show you how we're going to do it. Then there's going to be a kind of a shortcut. But here's the whole idea. First off, so absolute value of x is either x or negative x if x is greater or equal to 0, if x is less than 0, right? Okay, so we're going to split this up into its two cases. If x is greater than or equal to 0. So since x is greater or equal to 0, what can I replace the absolute value of x with? Just this. Okay. So I go x is less than or equal to 5. Then we know the solution is this. X is less than or equal to 5. However, it has to be both greater than or equal to 0 and less than or equal to 5. So it's a compound inequality, basically, which would all be these numbers, 0 to 5. So it's all these numbers. Okay. So that's part of our solution set. The other part is if x is less than 0. If x is less than 0, what do I replace this with? It's equal to negative x. And then I got to get rid of that negative. And how do I do that?
Multiply by negative 1.
Multiply by negative 1. And when we multiply by a negative, we have to, yeah, sorry, it's supposed to be a negative. Greater than or equal to negative 5. So all the numbers that are less than 0 and greater than or equal to negative 5 is this solution set. Draw those numbers. So the inequality solution set is this and this combined. So it's negative 5 to 0 union 5 0 to 5.
Is there a reason why you can't just write negative 5 to 5?
We're about to get to that, yes. Yes, so you combine these two sets. These are just this set right here. Agreed? Everything in red and green is all of these numbers, this set. This would be an equivalent compound inequality, right? The solution set to this is this exactly right here. Okay, so the shortcut, whenever we're given any absolute value is less than or equal to a number, we're not going to go through both of these steps because the shortcut is simply you rewrite it without the absolute value, and then you put the same symbol to the left And then you put the opposite of that number, -5, which is exactly what we got here. And this is a compound inequality. Is this an and or an or?
And.
And. Has to be less or equal to 5 and greater than or equal to -5. Let's try another one real quick. We'll make it a little bit complicated. And here we don't have just x, but it doesn't really matter. So the shortcut is to make a 2-for-1 and inequality, compound inequality. So we go 3x plus 4 less than or equal to 10. And then we put that same less than or equal to sign on the left side. And we put the opposite of that number over here. Now we got a compound and inequality. We solve it just like did we learn that on Monday? Something like that?
Yeah.
Okay, so we subtract 4 now. And once it's like this, we go right to our solution set. If we wanted to graph it, we could. 3 goes into 14, what, 4? 4 times. So what is that, 4 and 2/3? That would be it. Okay, so when can we do the shortcut here? Is only when the inequality points to the absolute value. Points away, we're about to do in a second. So let me show you the other way, or the other thing. Let's keep it simple at first. Okay. Again, we're going to split this up into 2 cases. X is greater than or equal to 0. If x is greater or equal to 0, the absolute value of x is simply x. Okay, so it has to be greater than or equal to 0 and greater or equal to positive 4. So what numbers are both greater or equal to 0 and greater or equal to 4?
Numbers are greater than or equal to 4.
Yeah, just the numbers greater or equal to 4. Like the number 2, this is true, but this is not true. So it has to be both this and this, which is just basically the solution set to this. And then if x is less than 0, since x is less than 0, what is the absolute value of x? It is negative x. And then we divide by -1, divide by -1, and flip. Here's the -4. So what numbers are both less than 0 and less than or equal to -4? All the ones that fulfill that. So that would be negative infinity to -4. So the solution set to this whole thing are both of these combined. We definitely have to write in 2 different intervals. We can put the union sign to combine into one set. If you wanted to graph them. It intuitively should make sense. Right back elementary school, they said the absolute value is the distance from the origin. So all of these numbers are farther away or equal to 4 from the origin, right here. And all of these numbers, distance is greater than or equal to 4 from the origin. Okay, so we end up with two different sets like that. Where this, all right, here x, this wasn't a good one. This one, simple. The absolute value less than or equal to 5. So the distance from the origin is less than or equal to 5, which are all these numbers. Okay, we don't care if it's the left or the right. Okay, so the shortcut for this one is when the absolute value is pointing away from the inequality is pointing away from the absolute value. You rewrite the same thing, just like we did for the other one. But then we have to write or x, and you flip, and you flip. Less than or equal to -4. And then this is a compound or inequality. And then you solve those separately. So let's do another example. It's a little bit more complicated. So is this the 2 for 1 and, or is this the or? We have to write two separate ones. Is the or points away? It's the or. Right. A distance is greater. It's going to have two separate things. So we go 2x plus 3 greater or equal to 5. We just copy without the absolute value. And we write or 2x plus 3. And then we flip the inequality sign, flip the positive sign. So it becomes less than -5. These we have to solve separately. We can't do it 2 for 1 like the previous example. So -3 to -4. 1 to infinity. So that's the solution set in interval notation, and then the graph would be. Okay, so again, the two shortcuts. If the inequality points away, we gotta write two separate ones. Write it without the absolute value, write the thing inside the absolute value, and then we flip the two signs, the sign of the inequality sign and the from positive to negative, and solve them separately. Let's try another one. So, what do we gotta do first?
Subtract 5.
Subtract 5. Is this the 2 for 1 and, or is this the or? The and. It's gonna be. So we go 6 minus 2x less than or equal to 2. And then we put the same sign on the left side and we flip. Opposite of this number there. And we subtract 6 minus 6 and 6. I'm gonna be real careful here. When we divide by the -2, what do we have to do? Okay. And before we write a solution set, I'm just going to flip the entire both inequalities. So I'm going to put the 2 over here. We still got to point to the 2, the x, got to point to the x, and the 4. And so it's all numbers between 2 and 4. Actually, it still does work, but let me change it to -12. That's what I wanted. What do we got to do first? Yeah, very important. We got to get the absolute value by itself before we do anything else. Divide by -3, divide by -3. what do we have to do with this? Gotta flip it around. And is this the and or the or compound? Or gotta write two separate inequalities. X minus 5 greater or equal to 4. Or x minus 5. We flip and we flip less than or equal to negative 4. I don't want to do that, but so greater than or equal to 9, less than 1. What am I doing? So it's negative infinity to 1.